All right, y'all. We are looking right now at the 3-12 notes. This is just sort of an extension on the stuff we've been talking about with solving quadratic equations. I wanted to reintroduce a concept right here called the quadratic formula. Okay, this is something that's a very popular way to solve quadratic equations. This is something that's introduced back in Algebra 1, so you may or may not remember having seen something, a big old ugly formula like this before. Okay, here is the way that I remember it. Now, when you take your tests, when you do any of your homework assignments, of course you're going to be able to look at these notes. But um, I still, I still like to give you a little memory device if there's one available. I like to give you a memory device. So here's how you remember the quadratic formula. Okay, to the tune of "Pop Goes the Weasel." X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so there's that. And what that does is it gives you the solution. Okay, now y'all know that most of the time on a quadratic function or a quadratic equation, you've got two different solutions. That's where the plus and minus comes in. Okay, this thing right here, that means we're actually splitting this in, and one solution is negative b plus that square root over 2a, and the other solution is negative b minus that square root. Okay, so that's where the two solutions come from. This is a useful formula when you can't factor. So, like for example, number one. Uh, on example number one, we have a quadratic equation. You see the left side of that equation? Like if we were trying to factor this, you'd be looking for two numbers that multiply to give you a product of one and add to give you a sum of three. Well, let's be honest here. Those numbers don't exist. Okay, there's no such thing as numbers that'll multiply. There are no whole numbers that will multiply to a product of one and add to a sum of three. So, what that means for us is we can't use factoring to solve this equation. We're going to have to use the quadratic formula. Okay, so all we're going to do, is take our a, b, and c. Okay, we look at this one. We see that a is 1. We see that b is 3. We see that c is also 1. So when we plug everything into that formula, that's our a, b, and c that we're using for the formula. Okay, I'm looking at negative b. So that would be x equals negative 3 plus or minus a big old square root. And underneath this square root, we have b squared. So that's 3 squared minus 4 times 1 times 1. That's a times c, right? And then that whole thing is all divided by 2a, which is 2 times 1. Okay, this right here, this big old square root, that is not complicated. Okay, this right here is something that you can evaluate in the calculator. Now, I will say this. If you're going to use the calculator to evaluate things, be careful and just make sure that you don't mess anything up. Okay, and here's what I mean by that. There's some stuff, like you see all underneath the square root, okay, all underneath the square root right in this little area, you know that 3 squared is 9. You know that 4 times 1 is 4. Okay, you don't have to do all of that. You can simplify it down as you go and have negative 3 plus or minus the square root of 9 minus 4. That's a little bit easier to deal with, right? Or 2 times 1. Okay, if you didn't even want to use the calculator, you could leave this as a perfectly good answer. Okay, your two solutions are going to be one solution would be x equals negative 3 plus square root 5, all divided by 2. And the other solution would be x equals negative 3 minus square root 5, all divided by 2. If you wanted to leave your answer right there and just have that as your two solutions, that would be perfectly okay with me. Okay? If you were looking for a realistic answer, something just something that's easier to wrap your head around, something easier to think about, you can type that into the calculator. Negative 3 plus square root of 5. Take that and divide by 2. Okay, that means this answer right here is approximately, x is approximately negative 0.382. And our other answer, x is approximately, okay, we're going to take this time, we're going to subtract it instead of adding. So we go minus square root of 5, and then divide by 2. X is approximately negative 2.618. All right, that's how you would write the answers if you wanted a decimal approximation. All right, now check this out. You could do this the way we've done it before too with graphing. Okay, if you wanted to put this function into y equals, okay, you could do that. You could go x squared plus 3x plus 1, and it would give you a parabola right there on the graph, the same way any other quadratic function would do. And then if you were finding the intercept, you'd hit your second trace too. Okay, your left bound, right bound, about negative 2.618. Yep, that's what we got. And the other one, it would work the same. Okay, I just do that to show you that it does work the same. All right, take a look at problem number 2. Okay, problem number 2 is going to be a little bit more complicated, but still not really all that bad, because when you look at it, we've got a equals 6, b is negative 11, and c is negative 10. Well, when we plug that into the formula, x equals negative b, right? 11 plus or minus the square root of b squared. Okay, if you don't remember all your multiplication tables, b squared would be negative 11 times negative 11, right? Okay, that's negative 11 squared, which we know is 121, minus 4 times 6 times c, which is negative 10. Whole entire thing over 2 times a, which is 2 times 6. Okay, let's simplify down where we can. We just said negative 11 squared is going to be positive 121. Let's look at your next one. 4 times 6 times negative 10 gives you negative 240. Now, here's the thing. When we're simplifying down, you got to be careful, right? You got to be careful and simplify this down. 11 plus or minus this square root is going to be 121 minus negative 240. Well, when you're subtracting a negative, that's the same thing as adding positive 240, right? And then that whole thing is over 2 times 6, which is 12. Okay, so again, if you wanted to simplify this down, okay, you can find a decimal approximation. Actually, as I look at it, I think this time it's going to end up as a whole number. Square root of 121 plus 240. Well, that's 361, and the square root is 19. So what we have right here is 11 plus or minus 19, whole thing divided by 12. It ends up being a whole number this time instead of a decimal approximation. Okay, so one answer is going to be, here's your two solutions, right? X equals 11 plus 19 over 2. The other one is 11 minus 19 over 12. Not over 2, excuse me. It's over 12. Okay, so this one right here, 30 over 12. Okay, we think about 30 over 12. Well, that can be reduced, right? If we reduce that down, we divide by, let's see, we could divide by 6. If we divide by 6, that makes it 5 over 2. Okay, if you were not sure about this, you could go 30 over 12. Okay, it gives you 2.5, which when you hit math frac, that's 5 over 2, just like we were expecting, right? Then our last one, x equals negative 8 over 12, which also reduces down. Negative 8 over 12. Okay, that's a repeating decimal. When we hit math frac, that gives us negative 2 over 3. All right, so that's our two solutions in fraction form. If you wanted to leave those in decimal form, that'd be fine with me too. Okay, so that's just your quick refresh on the quadratic formula. Okay, we're going to talk a little bit more about it. We're going to talk a little bit more about quadratic formula in tomorrow's lesson. But as for right now, that's really about all you need right there. Okay. Now, one quick thing that I wanted to mention about solving equations. Okay, this is a skill that I was reminded of when I was working with some students on STAR test preparation. Okay, sometimes when you are solving an equation and that's all the problem is asking you to do, sometimes we get really bogged down and overthink it. Okay, so something I want to try right now is using a graphing calculator. I want to do something that you may have seen as a testing strategy when you're taking a STAR test. Okay, I want to look at the two sides of this equation as two separate functions. Okay, if we type in the left side of the equation into y1, negative x squared, we put the right side of the equation in y2, 2x minus 2. Okay, what this does for us is it makes a graph where one of the things is a parabola, that x squared part, and the other graph is a line, that's the 2x minus 2 part. Okay, if we were looking for solutions to this equation, what we would do is we could just find where these two lines intersect each other. Okay, this is a very old skill that is sometimes taught as STAR test preparation because a lot of times there are problems that just ask you to solve an equation and there's a bunch of different ways you could solve it. And this is a pretty quick and easy one. All you got to do is look for the intersections. Okay, so if we're doing that, we would hit second trace 5. Okay, second trace 5. And then you're going to scroll as close as you can to where they cross over and then hit enter 3 times. Okay, scroll and see how close you can get to right on top of that and then hit enter 3 times. This gives us an intersection, one of our solutions, x equals negative 2.73. We'll round it off right there and I'll go ahead and change that to the little curly equal sign so we know it's approximate. That's not an exact answer. That's approximately 2.73. Okay, I'm going to do the same thing to find this intersection point up here. Okay, we hit second trace 5. Scroll over, get that cursor as close as you can to the crossing point. You hit enter 3 times, and this gives us our other solution. X equals, that is approximately, we'll say 0.732. Okay, so in this case, these two graphs cross each other in two different spots, and that means there are two different solutions. Okay, if these graphs had come up and only crossed in one spot, like if this line came up and just touched the curve and then peeled right back off, there would only be one solution. Look at this next one. Okay, this next one, I'm going to make that first side x squared plus 1. I'm going to make this other side just straight up x minus 1. All right, let's see what we've got here. There's our x squared minus 1 coming first. And here's 1x minus 1. Now here's a question. Do these graphs ever touch each other? And obviously the answer is no. You can see the parabola comes down and then it turns around at that vertex, right? That's what the vertex means. It's the turnaround point. Okay? This line goes straight directly underneath it, never actually crosses over. And since there is no intersection, there is no solution. All right? So I know the two parts of these notes don't really match up with each other. This is kind of a combination of a few different lessons just all put together. Okay, and I didn't want to make anything too difficult. So that's all we've got for today. The homework assignment is very much like this, very closely related. There's a couple of problems on the quadratic formula and a couple problems on general solving where you could use any number of methods. I just wanted to show you this particular one where you look at the two graphs on each side, the graphing each side of the equal sign separately and looking at that. All right. That's all we've got. So y'all take care and have a good one.